let us understand this concept which is called as the ripple factor. This we are talking in respect of the rectifier circuit. We have discussed the output of rectifier in case of half wave rectifier, in case of full wave rectifier, and now all of us remember what kind of output we are having. So based on that we will go for this topic. So first of all we should be knowing this thing, that the output of rectifier is pulsating DC. We know that the output of rectifier is not pure DC, it is pulsating DC, which means that it is consisting of DC component and AC component. So this AC component is nothing but ripple. This unwanted AC which is available at the output of rectifier along with the required DC is called as ripple. We know that the definition of the rectifier is that the circuit which converts AC to DC. So according to that we should get the complete DC at the output, but unfortunately we don't get the pure DC, we get the DC along with some AC. So that unwanted AC which is available at the output of rectifier along with the DC which is required. So this unwanted AC is nothing but the ripple, right? So that's why we have the definition of ripple factor like the ratio of RMS value of the AC component to the average DC component in the rectifier output is known as ripple. So if we take the ratio of AC component at the output of rectifier with respect to the DC component which is available at the output of rectifier, so that equation can be called as ripple factor. So accordingly the equation for the ripple factor will be given like this. So here you can see ripple factor is nothing but the ratio of RMS value of AC component divided by average or the DC value of the DC component. So this is nothing but the ratio of IAC divided by IDC. To explain this topic in the further better manner, I will require one diagram that I am going to draw here. Let us consider the current which is consisting of DC value, let us say like this, as it is DC so it will be constant. So this is its value, let us say IDC, but this component is having AC along with that. So that's why let us mix the AC here. So in this way this waveform is now consisting of the DC current as well as the AC. So this I can say as a AC, right? So this is nothing but the RMS value. So in this way this we can correlate with the output of rectifier. This is not actually the output of rectifier, but we are just making this waveform useful for understanding our concept. So here this is waveform which is consisting of DC as well as the AC component in it. So in this case the RMS value of the total output current is now given by the equation of IRMS, which is IRMS is equal to, as it is RMS means root mean square deviation, root mean square, okay, so it is root and then we are considering the DC as well as AC and their square, so that's why it is IDC square plus IAC square. So this is the equation for IRMS. That is what I have written. RMS value of the total output current is given by, means its RMS value. Now from this equation, by making minor modification, what I can take, I want IAC on the right hand side, remaining all term on the left hand side. So I can modify this equation like IAC is equal to under root. Now if you solve further you will also get this. It can be given like IRMS square minus IDC. I hope you can understand, right? It's a simple. We have taken this outside and this we have taken inside. So in this way the equation is modified. Now further what we can do is we can divide both side by IDC, because what I am interested in the ratio of IAC by IDC, because I am interested in calculating the ripple factor. If you remember, in the previous slide I have shown you the equation for the ripple factor, right? So that's why I am doing all this thing, because I am interested in getting this IAC by IDC, and that's why this modification I am doing. So now, after dividing throughout by IDC, what I am getting? I am getting IAC divided by IDC is equal to, here, 1 upon IDC in bracket, or this whole term as it is, IRMS square minus IDC square, right? Now we know that what this equation is. This is nothing but the ripple factor. So we know ripple factor is given as IAC divided by IDC. So this is nothing but the ripple factor, and we write this as, so ripple factor. Now we got the equation for the ripple factor, which is this, right? So 1 divided by IDC under root this whole term IRMS square minus IDC square, right? Now, for indicating this ripple factor, generally we use one symbol. So this symbol is this. So now further, what I will do, I will take this this IDC inside the square root. So if I take it inside the square root, what I am getting, this IRMS square as it is, but I am taking IDC inside the square root. That's why here I will take IDC, and if I am taking it inside the square root, I should take its square, right? So that's why it is a combined square of this ratio IRMS divided by IDC minus 1. So that's why this is the equation for the ripple factor, which is nothing but under root IRMS divided by IDC bracket square minus 1. Now, as we have this equation, which is for the ripple factor, under root IRMS divided by IDC its square minus 1, let us find out the value of ripple factor in case of half wave and full wave rectifiers. First we'll go for half wave rectifier. We have already derived the equation for IRMS in case of half wave rectifier. We know it is given IRMS in case of half wave rectifier. If you remember, it is IM by 2. Also, the equation for IDC in case of half wave rectifier we have derived, and it is IM by pi. So what we have to do, we have to simply put the value of IRMS and IDC here. So if you put this, what we are getting, the ripple factor in case of half wave rectifier is given like, now I will put IRMS is equal to IM by 2. So it is IM by 2 divided by IDC. So this, so it can be written like multiplied by pi by IM, right? And this is in bracket and bracket square, and this complete minus 1. Solving this further, this IM will get cancelled. Pi by 2, if I calculate its value and take its square, and doing all this thing, if I solve, I will be getting the value of ripple factor in case of half wave rectifier is 1.21. This is the value of ripple factor. In percentage, if you take, you can see how much higher value of ripple factor we are getting in case of half wave rectifier. Now let's check the value of ripple factor in case of full wave rectifier. So for full wave rectifier, if now I try to calculate, again I will be putting the value of IRMS and IDC, but in case of full wave rectifier, the IRMS is given by IM by root 2 and IDC is given by twice IM by pi. So let's put this value in the equation of this ripple factor. So what I will be getting, it is given by ripple factor in case of full wave rectifier is equal to, now again, under root these terms. So it is now Im by under root 2 multiplied by this pi by twice Im square minus 1, and you solve it further. After solving it, what you will get, the value comes to be 0.48. This you try to calculate at your place also. So the thing is that here what we have to conclude is the ripple factor in case of full wave rectifier is 0.48. If you take it in percentage, still it is less value as compared to this. So it shows that in case of full wave rectifier, the ripple factor is very less, and ripple factor is an unwanted parameter, because we have seen what is ripple. It is nothing but the unwanted AC present in the output of the rectifier. So we require that the ripple factor value should be as less as possible. So that is achieved in case of the full wave rectifier, and that is also one of the reason because of which the half wave rectifiers should not be used.